In this video, we're going to get into our first technical topic in this section, where we're going to start off with layer 2 technologies. I'm going to start off with the DTP and port security, not because they're related to each other directly, but more because of the fact that they deal with the same type of port or ports. And then we're going to get into VLAN ACLs, port ACLs, things like that. Depending on how the time is, after I've covered both topics, we'll see where we go from there. So, without any further ado, Dynamic Trunking Protocol, or DTP, is it's a negotiation protocol. And what DTP is designed to do is negotiate the operational and administrative mode of a Cisco switch port. Now, it's enabled by default on all Cisco ports out of the gate on the Catalyst switching line. I don't know if that's the case for Nexus or any of the other platforms that have layer 2 ports out of the gate, but I do know it is the case for just regular dynamic ports. They are in the mode of dynamic desirable. Now, because it's in dynamic desirable, that's the dynamic desirable is more of the initiator, and dynamic auto is more of the responder. It's whatever you tell me to do. So think of it like this: dynamic desirable is the master, and dynamic auto is the slave. So the master tells the slave what to do. That's fine if you don't care about what happens in the network, or if it's a very small environment and you're dealing with what I consider to be prosumer grade hardware, which means that whatever happens. A lot of times I'll walk into a very small office for a customer, and we'll be dealing with a $50 endpoint that's terminating an internet connection that'll run a link down to an 8-port switch, and that's what everybody connects to for internet access. Their last concern is port security or anything like that. Not that that's not important, but to them it may not be. So understanding where DTP comes into play is kind of a big deal. Now, the reason why it's kind of a big deal is in your larger infrastructure environments, like an enterprise, whether it's a small branch office or at the main headquarters location where your CIO, CEO, CTO sit every day. So what dynamic trunking protocol can potentially lead to an access is what they refer to as Vlan hopping attacks. And basically the idea with these guys is you are leaving enough information available on the network to be able to jump from one VLAN to the other. Normally, if you want to move between VLANs, you need to be able to route it. And if that's not the case, or if you need to be able to route it, if you need to jump between VLANs, which is just a broadcast domain, then you need some sort of layer 3 device, whether that's a firewall, whether that's a router, whether that's a layer 3 switch. At the end of the day, it really makes no difference what it is, just that you have a device that can route between the different VLANs. Because a VLAN is a broadcast domain, and it's also typically a subnet. Now, that's not the one thing that I often find that's interesting about people that are in the networking space, especially the engineers that have like a CCNA and stuff like that. The way that is taught in such a manner to remove any confusion. And the reason I say it that way, and the reason I bring it up, is because the fact that that's actually not 100% accurate. So what I mean by that is when you have a VLAN, literally all you have is a broadcast domain. I can do way more with it than just one VLAN or one subnet, because at the end of the day, its job is to maintain a MAC address table, and away you go. Now, there's another protocol that's typically used in layer 2 environments called ARP, the Address Resolution Protocol, and we'll talk about how that comes into play later on. Where DTP comes into play is you have a VLAN and you can apply multiple IP subnets to a single VLAN. And if you've never done that before, if you ever look on a Cisco device, a router or a switch, ASAs don't support this, and you type in an IP address, so you type in IP address 10.1.1.1/24, and then you do a spacebar and the question mark, the secondary command that you see there makes that a secondary IP, which means you can have more than one IP address assigned to an interface at the same time as long as they don't overlap. So you can't have 10.1.1.0/24 as a primary and 10.1.1.0/24 as a secondary. They're the same subnet. So it's either that's going to be the primary or that's going to be the secondary. It can't be both at the same time. But I can create multiple secondaries and have them be able to forward the traffic at the same time inside that subnet, because it's just a broadcast domain. And this is where the VLAN hopping attack comes into play. Not specifically in the subnets, but in the ability to pad the traffic. So in the service provider world, you may have heard the term .1Q in .1Q, or Q and Q for short, where you have a service provider backbone transport VLAN, and then you have a customer access VLAN. Well, the service provider backbone VLAN that's used to transport the customer traffic through from the ingress device to the egress device at layer 2, that VLAN ID is different than the customer's VLAN ID that it sends towards the provider that is used to pad. So if you were to envision this, you've got two different VLAN, two 802.1q tags. You have the outer tag, which is the service provider's tag, and you have the inner tag, which is the customer's tag. The outer tag gets you through the service provider backbone, and the inner tag is how the customer's traffic is differentiated from another customer's traffic, and how they are prevented from bleeding into other customer networks and stuff like that. This is where the VLAN hopping attack comes into play. Now, one of the things that I'll caution you on is I have actually never seen this executed. I've heard plenty of security engineers and security instructors talk about it, but I have never once seen it actually executed as an attack. So I am skeptical that it's actually a possibility, only because of the fact that I haven't seen it firsthand. Not to say that it doesn't exist, because there's a lot of things that people are able to exploit and execute and exploit vulnerabilities. That is not something that I can see happening. Not that it couldn't, but the whole point of DTP is to prevent that from happening. So in a hypothetical use case, if you have a device, let's say a PC, that connects to a switch, that switch port that the endpoint connects to should be in the mode of access. Well, unless you specifically state it to be access, it's going to be switch port dynamic desirable. Now, that's going to be its default administrative configuration and its operational state out of the gate. Now, if I'm worth my salt, I'm going to change that to be switchboard mode access, which does not enable DTP. But if I'm not worth my salt, maybe I'm just a regular guy that that was tasked with deploying a small network, and you don't have the back end or understanding of what's actually happening. You just know that if you connect this $50 device that you bought at your local electronics store, like a Best Buy or maybe Fry's Electronics, or wherever, depending on where you're at in the US. You plug your internet circuit into this thing, you get an IP address, and you plug in a couple of PCs into the switch, and magically you have internet. It just starts to work. That's typically where most people stop if they don't understand what's going on. But with DTP, if I'm savvy, I can actually form a negotiation with my with the upstream switch and form a trunk link with them. This is where the problem comes into play. Because dynamic trunking protocol is a dynamic decision, as long as you can agree upon the encapsulation or the mode of operation, that's when the problem comes into play. And like I mentioned a minute ago, I've never actually seen this executed. I'm just familiar with the concept. That's why I'm bringing it up now. Now, when you have it on the flip side, the whole point of DTP is to negotiate whether the port is in a trunk mode or whether the port is in an access mode. If BPDUs, bridge protocol data units, are not received in on the port, that's going to be the trigger for the switch port to determine whether it's a trunk or whether it's an access device. And at that point, and only at that point, does it make that decision. And then once it determines it's a switch, it's actually listening for the encapsulation on that port. If there is encapsulation of .1Q, then the port automatically negotiates 802.1Q. If you do a show interface as trunk on a switch where DTP is enabled and .1Q has been detected, you'll see it say N-802.1Q. So it'll tell you what the trunking encapsulation is. Now, if you do a show interface gig 0/2 switch port, you're going to see its DTP status. Whether that's in on or off, you'll see an administrative mode, and you'll also see an operational mode. The administrative mode is going to be what is globally configured at the interface level. Dynamic desirable, trunking, access, whatever the case might be. And the operational mode is going to be what was ever negotiated or hard-coded at the time. So my recommendation is anywhere you can, disable DTP everywhere you can. I do not like using it. To me, I understand how it works, and that's as far as I ever take it. I never let a switch just hang out as an active endpoint. I would rather shut down all the ports and put them into an unusable VLAN, a VLAN specifically that doesn't have a default gateway that goes nowhere, and I automatically shut the port down. So it gives me a couple layers of security. I have this layer of security where there's no egress point for the VLAN, so you can't accidentally have a device plug into that VLAN that's enabled, or a port that's enabled in that VLAN, and gain access to some part of the network, and then because the VLAN, the port itself is shut down out of the gate, the port doesn't even work when you plug it in. So you're giving yourself a couple layers of security in that respect. Albeit they're small, but regardless of how you want to look at it, security is always a layered approach, and the more layers you can put in play to prevent something from happening, the better off you're going to be. Now that's DTP, and I won't go into too much more detail on that because it's actually pretty straightforward. The next topic we're going to talk about is port security. Now, port security in itself is it's a very straightforward concept, but it can be semi-difficult to understand what it actually is doing. And I just recently went through and demoed it again just because of the fact that it had been a little while since I had touched it. I'm familiar with the concept and how it works, but I had never really gone to the lengths of, okay, well, let's test this out with all the different modes and error recovery, disable, and all that type of stuff. So I did that. And I was actually a little disappointed because I was expecting it to be more interactive than it was, and it was not. So port security is a technique that is used to protect a port that connects to an endpoint, whether that's a server, a PC, an access point, whatever the case might be, from being the port that gives access to a CAM flooding attack. Now you might say, well, what's a CAM flooding attack, Rob? Well, a CAM flooding attack is basically a method of trying to flood the content addressable memory table, or the CAM table, with a bunch of bogus or rogue source MAC addresses. That is the goal of port security. Now, by default, all ports in a switch port are configured without port security, and for good reason. So instead of allowing all ports to just allow everything to come through, or I'm sorry, that's the default operational mode. They will allow a port to accept as many source MAC addresses as it receives and go from there. Now, that's not necessarily a bad thing, and I'll give you a couple of examples of how this, where this comes into play. The first example is on an access point, because you might have, let's say you've got two SSIDs that are being advertised from that particular access point. So you see the SSID, you click on it, you type in the username and password or whatever your authentication mechanism is, the certificate or password or whatever it might be, and then you're able to access the rest of the network. And because of the fact of the way the wireless is set up, you're able to gain access to whatever you need. When you look at the MAC address table on a switch that's got an access point connected to it for that particular interface, let's say for instance you have a 3750X running 15 code and you have an access point, let's say an AirNet 1832 plugged into the switch port and it's powered on, ready to go. It's broadcasting an SSID or multiple SSIDs, and you've got a bunch of clients associated to the two different radios. What's going to end up happening is that particular interface that the access point connects to is going to show a large amount of MAC addresses being sourced from it. So there's a bunch, let's say that there's 20 clients, 10 on each SSID associated to that access point. They're coming in on different VLANs, because that's typically how you're going to differentiate it. You map an SSID to a VLAN. Once you've done that, you can go ahead and you'll see a bunch of MAC addresses showing up on the interface. Now, there's nothing wrong with that, and that's a perfectly legitimate way of deploying a wireless network. As a matter of fact, that's how it's typically done. This would be a bad example for port security, because you're expecting more than one or two MAC addresses on that port, so therefore port security would be a bad thing. Now, not to say that you couldn't put port security in there as a way to limit the number of MAC addresses that are learned. So, for instance, a good rule of thumb that I found on some of your later AeroNet access points is no more than 40 users or 40 clients connected to a particular access point. That's just what I've used over the years, and it seems to be a pretty good number. On some lower model platforms like the 1100 or the 1140, you might get into too many clients trying to associate, and that's just a hardware limitation. Newer hardware is able to support more and go from there. Now, when you get into a situation like that, this is a bad example, or not a bad example, but it's a bad use case for port security. It can still be used for port security to allow a maximum amount of MAC addresses to be learned, and that's completely feasible. But typically speaking, port security is not going to be placed on an interface where there's going to be lots and lots of source MAC addresses. And this would be another example of this type of port would be a switch port that connects down to like an ESXi server, where there's the potential of lots and lots of source MAC addresses being generated by the ESXi server with the amount of VMs that are created. Let's say you've got 30 VMs created on a particular ESXi server. You're going to have, hypothetically, 30 source MAC addresses coming in on that set of those ports. Now, that's completely possible and a very valid design. Not always the case, but certainly possible. Another use case where port security wouldn't make sense. Now, where would port security make sense? Port security would make sense on an access port where you have an IP phone that connects from the switch, or connects the switch to the PC and go about your day. That's going to be a minimum of 2 MAC addresses. So you could go in there and state, you know what, I'm going to put 2 MAC addresses as the maximum, and you're going to take both of the MAC addresses that are learned and convert them to a static configuration. By doing this, you're going to be taking those MACs and you're going to be hard coding them into the running configuration of the switch, so that only those 2 MAC addresses are able to be learned. Now, when you have that type of situation, that actually benefits you a lot better than a situation where you're not controlling it at all. Now, I'm not saying this is the only way to do it, but it's more or less just typically a guideline that I follow when I'm deploying. I'm trying to figure out which switch ports make sense to apply port security to. Not every switch port makes sense. Understanding what the switch port does or what type of traffic will be flowing over it is very, very important. You know, an access point connected interface or a ESXi server connected interface, those are 2 typically bad examples, but it can still be put there to limit the amount of source MAC addresses as just a precaution. Now, there are a couple of specific aspects of this that we need to go over, just because of the fact that we need to understand what it is that port security is going to be doing. So if you take a switch like this and I connect my PC down, right? Here's my laptop hanging out on the switch port. If I take my switch port like this and I just have it normally operating, all day long I should learn 1 MAC, which is going to be the PC's MAC address when it starts to communicate with the switch. Okay? And whatever VLAN that is, that gets applied to it. Now, there are some use cases where I've seen it where you'll have a switch port will have a link coming down to another switch, maybe a little A-port job that an A-port switch. Maybe it's unmanaged because it sits inside of a conference room and maybe wireless is sparse in that area. This is very common. I do see it quite a bit. So instead of running wireless to a particular area of the building, it's easier to run a network drop where the access point might connect to, and now you've got a dedicated hardwired 8 users that can plug into this. So now I do this. I plug in a bunch of PCs here, everybody's good, and then I learn 5 MACs here, right? So this may be an acceptable use case, although on the other side it may not be. Now, I've seen both sides, or seen both implementations, and neither one is bad. But you just have to understand what the use of the port is going to be in and be able to make your decision from there. Now, with that said, I take this right here and I go, okay, well, is this a bad thing or a good thing? Then you might have to call somebody or ask a couple questions to get some clarity. But over here, if all of a sudden 1 started to grow to, say, 20, that's something that I need to be concerned about. This is where port security would come into play. Why might I jump up to 20? Well, there might be a program running here, and I'm just going to go draw some mean eyes, and this guy's he's winking at me at the moment, but this guy's upset. Something's not right, and he wants to take it out on the network. So he goes out and he starts generating a bunch of source MAC addresses with a bunch of bogus DHCP requests. We'll talk about DHCP snooping and dynamic ARP inspection in an upcoming video. But basically, what ends up happening is 1 grows into 20, grows into 100, grows into 300. Now, when you start hitting the upper limit of a switch's CAM table, so how many MAC addresses can the switch support globally? So regardless of how many it's learning on a particular port, there's going to be an upper limit of the total capacity the switch can support. Well, let's assume that this is 1024. Now, if your maximum amount of MAC addresses is 1024, then depending on the situation at hand, this may be a really, really high number, or this might be a pretty average number. Now, I've worked in environments in more of the data center type of the world where you're stretching layer 2 between multiple data centers, whether they are geographically, physically close, or miles and miles away. When you have a bunch of MAC addresses, this is where you need to be careful of how you handle this. So let's say, for instance, on average, that there are 400 MACs that have been learned on this particular switch. Well, that's not all bad, but as long as those MAC addresses have been learned the appropriate way, then no harm, no foul. But if you get a nefarious user that goes out and decides that he wants to bomb the network, he can start generating a bunch of bogus MAC addresses that are all going to be learned on this port right here, and you'll see the maximum MAC address count start to climb. You know, went from 20 to 50 to 80 to 150 to 300. So now you're encroaching on how many MAC addresses the total platform can support. Now, sidebar, how many, or what is the effect of a switch whose CAM table has been maxed out? Anybody have any idea? What happens when that happens? The switch will no longer learn MAC addresses or the port that they were received in on. So once you meet the maximum amount of MAC addresses that a switch port or a switch can handle, it reverts from switch-like operations, which is learning and intelligently switching the traffic between ports, to more like hub operations, where it says, you know what, I have no more resources to allocate to learn new MAC addresses on ports, so I'm just going to start flooding it out everywhere, out every VLAN and every interface, because I don't know where it's going. I can't learn it because I have no more resources. I've become a dumb switch at this point. Now, all of the MAC addresses that have been learned up to that point will still be intelligently switched. Anything greater than the maximum number will be hub switched, or basically just broadcasted out everywhere. And this is a last ditch effort to be able to handle the load, because the switch CPU may not be 100%, but the RAM or the memory might be pretty high with all the trying to maintain that CAM table. But irregardless of the situation, this is one way for it to try to mitigate that problem. Now, I don't really agree with some of the statements that I've seen online, and I'll keep them pretty mellow. But depending on the situation at hand, I am pro port security in a modern network. So what port security will do is you can put a maximum on the number of MAC addresses that can be learned, and this is, let's say you set a maximum to 5. Now you can set both dynamic and static MAC addresses at that point. Now when you do dynamically, you can convert them to be static in global config with the sticky command. Sticky is a keyword that you can use to take the learned MAC address, dynamically learned MAC address, and flip it to a static configuration and store it in the running config. When you save the config and reboot it, that MAC address stays. Now, if you have static, which means you actually come in here and you statically define the MAC address, both of these count against the maximum amount of MAC addresses that can be found, or can be learned, I should say. So that is something to keep in the back of your head when you're dealing with this, is make sure you understand what the capacity is. Now there are 3 different violations here. You have protect, you have restrict, and then you have shut down. Shutdown is the default operation, which means when there is a security violation, the port is then error disabled and shut down. Restrict will block any traffic coming in from the offending MAC address on that particular port, but it'll block all the traffic. It'll block all the traffic and won't allow it to proceed. Protect, and it'll also generate a syslog message. So you'll see on the CLI or in syslog messages showing up from the server or from the switch, hey, this particular port has exceeded the maximum configurable MAC addresses possible on the interface. Protect does exactly what restrict does. It drops the traffic, but it does not signal anything. So it's like a silent drop in the background. The user's unaware of it. The network is unaware of it. So that's why I never use protect. I use restrict or shutdown depending on the situation. If I'm in an environment where I can't afford to have a port get shut down, I'll put it to restrict and let restrict handle it. Now there's one other option here that's available to us, which is the error disable recovery. Now what this does is it will automatically go out and it will attempt to re-enable a port that has been error disabled due to a port security violation and try to bring it back up. Now what will end up happening is if the offending MAC is still present in the network and it can potentially be seen again, error disable recovery will try to keep bringing that port back up and back up and back up until, you know, a engineer or an administrator can jump in there and take care of that. So error disable recovery is great, but there might be some caveats with it as you're going forward. And that's pretty much it, folks. These are I wanted to cover dynamic trunking protocol and port security in this video. We did that. We're gonna keep moving along as we go forward here. Again, if you guys have any questions or would like to see a specific topic covered, please drop us a note in the comments below. Your feedback is really important to me, and if there's something that I haven't covered that you would like to see covered, please let me know. Until next time, guys, thank you so much for stopping by, and we'll catch you guys in the next video.